Okay, today we're going to talk about how conservation of energy and conservation of kinetic energy can mean something important, or COM and Coke. Okay, so this is helpful when dealing with perfectly elastic collisions. So in this picture, we have two objects that are colliding elastically. If that is the case, and it actually is an elastic collision, then these objects bounce off each other without losing any of the total kinetic energy. Okay, so that's how you know that you have an elastic collision. You have not only conservation of momentum, but you also have conservation of kinetic energy, or Coke. Okay. So you need both conditions for an elastic collision. Down here I have it written, if you need to figure out the conservation of kinetic energy, then all it is your Ke for A plus Ke for B before, so in this case this would be the before situation, is equal to your Ke for A and Ke for B after. Okay, so it looks very similar to the MAVA plus MBVB. It's just now we are noticing that this is the Ke equation, 1/2 mv squared. Okay, so to work out a problem, the problem that we had in the video yesterday actually happens to be an example of an elastic collision, and I'll show you how that works. So here is our before and after situation. Since we've already solved this, I'm not going to walk you through that again. But you can, again, this chart is very helpful for detecting a conservation of kinetic energy situation. Because again, you want to make sure that you plug in all your befores on one side and all your afters on another side. So if we plug in our numbers, we'll have 1/2 times 1.2 times 2 squared for A, and then 1/2 times 1.2 times -3 squared for B, and then after that we'll have 1/2 times 1.2 times -3 squared plus 1/2 times 1.2 times 2 squared. Some of you can probably see from here that these are going to be equal to each other. But one thing to make note of, with kinetic energy, the signs don't matter because the velocity is squared, so that makes the negative sign disappear. Okay, so if we simplify 1/2 times 1.2 times 2 squared, you get 2.4 plus 5.4 equals 5.4 plus 2.4. And lo and behold, we have 7.8 equals 7.8. So this is conservation of kinetic energy and conservation of momentum. So we have an elastic collision. All right. The way you'll be tested on this is you'll probably have some things where you have to figure out conservation of momentum, but then you'll be asked to identify it as elastic or possibly inelastic. Any collision where we don't have conservation of kinetic energy is technically called inelastic. All right? You're going to have some or all kinetic energy lost to either thermal or potential energy. Okay? Depends on the situation what it is. The picture here is actually showing a loss to potential energy because we're gaining in height. Okay? Or a collision where things get stuck together, which is the most common inelastic collision, that sticking together causes friction and therefore thermal energy is lost. Okay? One thing a completely inelastic collision, or sometimes referred to as perfectly, is when the two objects stick together afterwards. All right, so it is possible to have two objects bounce and hit each other and have just a little bit of kinetic energy lost, but then still bounce off of each other and be separate afterwards. Okay? So let's do another sample with that. All right, so the other problem from the video last night is an example of inelastic. Granted, this one you can tell right away because it does talk about sticking together, There are examples when they aren't stuck together and you have to use conservation of kinetic energy to confirm whether or not it is kinetic or inelastic. Or sorry, elastic or inelastic. Okay, so let's plug this in and confirm that we will not end up with the same amount of kinetic energy that we started with. So, first side, we have 1/2 times 90 times 2 squared plus 1/2 times 100 times -3 squared, and that's going to be equal to 1/2 times 90 times -0.63 squared plus 1/2 times 100 times -0.63 squared. All right, so this first one simplifies to 180 joules plus 450 joules, which will be 630 joules. And then on this side, we're going to have 17.86 joules plus 19.85 joules, and that comes to 37.71 joules. So those are not equal to each other, so you know you have an inelastic collision due to the loss of kinetic energy. Okay, so make sure you do the online form, and I will see you in class.